Swivel probes can be used with the FARO Arm to help you to capture sheet metal edges and other small, thin surfaces where you want to capture the data right on the surface and not have to adjust for the radius of the probe. Swivel probes are a custom probe, and I'm going to show you how to enter these probes into the software and then calibrate that probe so you can use it for measuring. What we have attached to the end of the arm is a swivel probe, and this particular one, you can see that the ball pivots on the end of the probe and it has a cutout in it. And the cutout goes exactly to ball center. So as you're gathering data, your part is going to ride at the middle of this probe to capture your data. And there's no need to adjust for the radius of the probe after you capture that data. This type of probe, because it pivots, has to be calibrated in a special way. Also, since it's a specific custom probe, it's not one that's readily available in the drop-down menu when you first install the software. So we have to enter it in as a custom probe. Let's begin in the software. From the keyboard, select the letter P, and the probe dialog will appear. Select Probe Management, and you can see that right now we're using this 6mm ball probe. From the drop-down, we can select our custom probe, but as I stated earlier, the swivel probe is not available in the list. In order to enter the swivel probe into the list, we're going to select the Edit button. In the top left of the window, name the probe, and under Probe Diameter, type in 0. The concept of the swivel probe is that you're going to be taking the data at ball center, so no diameter will be offset. Uncheck Guidance and select Create New. Notice that now Swivel Probe appears as our current probe. As you look at the picture, you can see a picture representation of a point probe. We know that's not the probe we have on the end of the arm, but since we see Swivel Probe as our current probe, we know that the parameters we entered in the previous screen are being used for this probe calculation. Now let's calibrate the probe. We're going to use the sphere calibration method. Select the sphere calibration button, and the software is ready to capture data. Now that we have the software set to calibrate the probe, we're going to bring the arm down and calibrate on the calibration sphere. For the swivel probe, we're going to do a standard sphere calibration in which we touch the ball of the probe to the ball of the calibration sphere. It's important as you're calibrating to make sure that you're touching the spherical surface and not the cutout surface to the calibration sphere. We're going to take 44 points in 4 sets of 11. The first set is going to be with the last axis of the arm vertical, and with your finger, you're going to adjust the probe as you go, hold it in contact with the calibration sphere, and take 11 points. We're going to start at about the equator and spiral around to the top of the ball. Once we have 11 points in that position, you're going to pivot the handle of the arm 90 degrees and take your next set of 11 points. After that set of 11, you're going to rotate the last axis horizontal instead of vertical. Take 11 more points in this position. The final set will be rotating this handle 90 degrees. 11 more points. And once you've taken those 11 points, the software will calculate whether you've passed or failed the probe calibration. The green light says that you've passed, and now you can measure with the probe. What you've just seen is the swivel probe calibration using the sphere method and how to enter in the swivel probe parameters into the software.